I want to do one more example that's sort of review of tracing across function calls in different scopes before we go forward, just so that we have at least one more point of reference. I really encourage all of you to try tracing this through by hand before watching the video and see how well things go. It's pretty common, like in a lot of parts of this discipline, to watch somebody trace code and say, oh yeah, that makes sense. But then when you try and do it yourself, it's not so easy. So I really encourage you, don't just watch and follow along and say, oh, that makes sense, but make sure you can actually do it yourself from scratch. And again, what method you use is up to you. Just make sure you can get it to work. So I want to trace this. This particular piece of code contains an example of one particular sort of cruel trick that is often present on exam tracing questions, which is that you will notice that the name X is used by just about every function and every part of the code for a lot of different reasons. And so if we're not careful, it's very easy to get them confused. And that's one reason that having some robust visualization can be really helpful. So I want to begin tracing. I'm going to treat this just like a paper exam question that's asking me to provide the output of the program. So I want to just run through the program and generate all of the output by hand. Now, normally, of course, we're going to start at the beginning of main. That's going to be the first line that actually gets executed. But it's worth noting here that we have a global variable. And, of course, the first piece of code I'm going to execute inside of a function is in main. But remember that global variables exist before any scope and after any scope. They exist in the global scope that exists outside of any function. And so when I diagram this out, I want to make sure that I actually represent that global variable and that it's there for the entire lifetime of the program. So here's going to be my scoping box for main. And then outside that scoping box, I'm going to place this global X. And its initial value is 999. So as of the beginning of line 15, this is the state of the program. This global variable is already in existence and will continue to exist even after main ends. Now, I begin executing main. I'm on line number 15. And just like in the previous example, we create our variables x and y. So x has the value 6, y has the value 10. And we'll notice, of course, that that means that as soon as I've done that, if I'm in this scope here and I ask for the name X, I'm going to get this. I'm not going to get the global X. The global X has sort of been shadowed in this case. I have no way of accessing it directly by name because I'm using the name X for something else in main. And then I get to line number 17, so I generate some output. And so main 1, I'm going to print out X and Y. That would be 6 and 10. And now I reach line 18 and I ask the question, is x less than y? Well, okay, so I'll just evaluate the expression. X is 6 and y is 10, so the answer is yes, x is less than y. And that means I'm going to jump inside of the if statement. And so just like in the previous video, the if statement is physically located inside of main, and that means that I will need to create a nested scope. So I put my nested scoping box here. This is the if statement that started on line number 18. And then I get to line 19. And on line 19, I create a variable called x, which I am allowed to do. I make a variable inside the if statement called x with a value 100. And on line 20, I use a C-style initialization, which is my right. So I'm allowed to do this. I need to be very careful to remember that we are still declaring a new variable. And so under all circumstances, a line like this will create something new called y, assuming this compiles at all, which it does. So that means I should expect there to be a new variable when I am done with this statement. So I'm going to put that there as a placeholder, and then I'm going to evaluate the assignment statement according to the first law of assignment statements, which is I have to first evaluate the right-hand side. So the right-hand side is just f of x. I'm going to want to call the function f here. Of course, I should fill in the value of x, so I'll rewrite this as f of, and I'm in this scope here, so I go looking for the value of x. The value of x is 100. So I call f with the value 100 as its argument. So I want to set up f on my diagram. So there's f. F takes as its argument one variable, which, as it happens, will end up with the name x. And so this single argument I pass in ends up taking on being assigned to the argument x here. And so I begin executing f with x set to 100. So I end up on line number 4. So on line number 4, in the scope of f, if I ask for the name x, I go looking, and of course, there it is. I find it inside the scope I'm in, which means I'll get this one. I will not get the global x. So line 4 is just printing out some output, so f, and I print out x is, and the value of x is 100 in the context of f. On line number 5, I say x equals x plus 10. And if I evaluate this according to the first law of assignment statements, well, in the context of f, x is 100, so that's 100 plus 10, which is 110. And I take that value 110 and I assign it to x. Okay, so that's, again, in the context of f, this is x. So I set this to be 110. And then I return the value 1000. And of course, that means that this value of x is going to end up going to waste, but that's valid. This is valid code. It's odd, but it's valid. So the return value of f is 1000, and I'm just going to go down and replace the call to f with the number 1000 here to make a note of that. And now f ends, and that means that f and everything inside of it is gone. So I've destroyed the scope for f, and now I return back to main, where I was in the middle of running this assignment statement on line 20. Int y equals, now I guess, 1000. So on line 20, I'm in this scope here, and so the name y resolves to this thing, and so I set this thing to 1000. And then on line 21, I print out more output. So main 2, I print out, okay, so in the scope that I'm in on line number 21, the value of x is 100, and the value of y is 1000. And then on line number 22, the scope ends. So on line number 22, I destroy this and everything inside of it to make sure that they are gone, that they are not going to confuse me later. And I'll just clean this up as well. So I get to line 23, and I generate more output. Main 3. And main 3 prints out x and y. Well, I'm now back in the primary scope for main, and of course x is 6 and y is 10. And then I get to line 24. Line 24 says call g, now g doesn't take any arguments, and then assign the result to y. Now, although I think this is a relatively simple assignment statement, I will still cross off the left-hand side for I guess, consistency. And I guess the first thing I have to do, therefore, is to call the function g and get its return value. So I'm going to need a box in the diagram for g. There it is. And I notice g takes no arguments, so I have nothing left to do besides simply run the function g, and that puts me on line number 9. And I print out g, x is... And then I use the name x. So I go looking inside the current scope for something called x, and I don't find it. And we know that if we can't find what we're looking for in the current scope, we're allowed to leave the box and look outside. And outside the box for g is the global scope. I'm not allowed to break into the scope for main. There is something out here, though, called x. It's this global x that's been lying around the whole time. And so I guess that means when I go fetch the value of x in g, I'm getting this thing. I'm getting the value of my global variable x. So x is 999. And then on line number 10, it says x equals 187. Well, again, I go looking for x in my scope for g, and it's not there. So the x I end up using is this one. So I set this to be 187. And then line 11, return x. So again, in g, the value of x is now, it's this thing, so the value of x is 187. That means the return value of g is going to be 187. So I make a note of that. I go write that down here, where I was making the call to g, and then g can end. And of course, g ending means its scope gets destroyed. Some good that did us, because of course there was nothing in the scope. But I destroy it, I make sure it is gone, and that brings me back to line number 24 in main. So line number 24 has been reduced to y equals 187. Well, in the scope of main, that is y, so I set this to be 187, and then I generate more output. Main 4. And I go looking for x and y in the context of main. Well, in the context of main, this is x and this is y, so 6 and 187. And we can see there with that global variable, notice that it was sort of harmless for most of the execution of the code, but there did come a point when I had I tried using the name x in a scope that did not have its own x, and that brought me to the global variable. And this is one reason why, using a rigorous approach, it's a lot easier to avoid accidentally entangling this global variable with all of the other variables named x that are being thrown around. Not only because it's easier to tell when you're using something global when you aren't, but also because I suppose there is a certain instinct people have when they see something like this to want it to be needed. That is, at every point in the code, they're wondering, when am I going to need the global variable? And if you're not careful, you end up using it a bit too early. It would be quite valid to give a tracing question full of global variables that for some reason never get used. It's the same psychological trick as giving a multiple choice exam where every answer is A. It's valid. It's not very nice, but it is valid. And one thing about tracing code is being confident when you're tracing that you are getting the right answer and not wanting to change things because it doesn't look right. It seems like no code would ever do this. Because in practice, if you end up tracing code, often it's because the code is broken to begin with. So whether or not reasonable code would ever do it isn't, I think, a good measurement of whether or not this code is doing that.